Hi everyone, today I'm going to talk about some sample problems related to homework 6. And this video is about the differences in two means and one proportion and two proportions. Let's take a look. The first question. To find out whether a new serum will arrest leukemia, 9 mice, always in an advanced stage of the disease, are selected. 5 mice receive the treatment and 4 do not. Survival times in years from the time the experiment commenced are as follows. Here I already get the mean and the standard deviation here. So at the 0.05 level of significance, can the serum said to be effective? Assume the two populations to be normally distributed with equal variances. So from the problem setting we can know sigma 1 equals to sigma 2, but unknown. And how can we see the serum to be effective? That means the x1 should greater than x2. Here's the 1, here's 2, right? So we write the hypothesis here. H0 is x1 equals to is mu. Mu1 equals to mu2, and h1 is mu1 greater than mu2. So here I'm going to use same mu1 greater than mu2. So second, let's take a look at the formula we're going to use. So it's the first one, no. So here it says sigma 1 equals to sigma 2, but unknown. So that's the formula we're going to use. So we'll just copy it here. So that in here the D0 should be 0. So for this problem, T equals to x1 bar minus x2 bar minus D0, then SP n1 plus n2 is a square root. So SP square equals to n1 minus 1 s. Okay. n1 minus 1 as 1 square plus n2 minus 2, n2 minus 1 as 2 square divided by n1 plus n2 minus 2. So we get the result here. We have the S, we have the N, so we have the result here. The SP is 1.6744 square. So T equals to, on the top is 2.860 minus 2.075 minus 0, and below is 1.6744 times 1 over 4 plus 1 over 5. So that equals to 0.69888. So 3, we're gonna get the T alpha. Because this is greater, it's not like it's greater, so the formula we use is mu1 greater than mu2. So T should be greater than T alpha. So here T alpha is n1 plus n2 minus 2. That is T.057 equals to 0.05. This T distribution 0.05 with 7 degree of freedom. It's 1.895. It's greater than 0.69888. So far we conclude that we cannot reject H0. Okay, so that's the first question. Let's take a look at the second. A marketing expert for a pasta making company believes that 40% of pasta lovers prefer lasagna. If 9 out of 20 pasta lovers choose lasagna over other pastas, what can be concluded about the expert's claim? Use a 0.05 level of significance. So here it says he claimed the proportion is 0.4, and so we can get the hypothesis is the probability equals to 0.4, or alternative hypothesis P doesn't equal to 0.4. So let's take a look at this formula, the one proportion. So what we need here is the P0, that's 0.4, and the X, this formula is going to be used. And so we have a true side of the rejection region. So for this, Z should equal to X minus N times P0. Here's P0. Oh, no, this is P0. Divided by N times P0, 1 minus P0. That equals to 9 minus 8, right? 20 times 0.4 is 8. And divided by 20 times 0.4 times 0.6. That equals to 0.456. So Z alpha over 2 equals to 1.96, and minus Z alpha over 2 equals to minus 1.96. So because 1.96 is less than 0.456, less than 1.96, so we fail to reject H0. That's the way you should know to solve the one proportion problem. Then let's take a look at the third problem. An urban community would like to show that the incidence of breast cancer is higher in their area than in a nearby rural area. If it is found that 20 of 200 adult women in the urban community have breast cancer and 10 of 150 adult women in the rural community have breast cancer, can we conclude that at the 0.05 level of significance, that the breast cancer is more prevalent in the urban community? So that's from the setting of the problem, we can know the P1 hat equals to 20 over 200, and the P2 hat equals to 20 over 10 over 50. So what they want to show is first the null hypothesis is P1 equals to P2, and the alternative hypothesis is P1 greater than P2. So let's take a look at how to solve the problem. So here, and the null hypothesis, and the test of this is like this, okay? And what we want is this hypothesis and this rejection criteria. So the Z0 equals to P1 hat minus P2 hat over P hat 1 minus P hat, then N1 plus N2. Is that right? Yeah. And this P hat equals to 20 plus 10 over 200 plus 150. This equals to 0.086. This is 0.1. This is 0.067. So we got those values. We can directly get the z0. The z0 should be 0.1 minus 0.067 divided by 0.086 times 0.914. Is that right? Yeah, I think so. Times 200 over 1 plus 1 over 200 plus 1 over 150. So this equals to 10, and then we get the z alpha is z.05. This is easy. This is 0.645. This is greater than 1.10. So we conclude that we fail to reject the H0. Okay, so that's a problem about difference in two means and proportions.